Okay, so welcome to the second part of the last lesson in derivatives. And so when last we talked, we were doing implicit differentiation, and so we're going to continue doing implicit differentiation, and we're just going to do some word problems with them. So we need to find the equation of a tangent line. So remember, to find the equation of a tangent line, we need a point, we need an xy point, and we need a slope. And so the slope is the derivative, so let's go ahead and take the derivative of this. And we're going to take the derivative implicitly. Okay, so it may be helpful to distribute this, so let's just write this as 4x minus 12, and we can write this as y squared minus 4y plus 4. And so taking the derivative, we get 2y, y prime, minus 4y prime is equal to 4. So we get y prime is equal to 4 over, factoring this out, I get 2y minus 4. Okay? So we know that x is 4. They tell us to find it at 4, and we need to find y. Also notice that there is no x in this equation, but we can find y. We can find y by substituting in 4 for x, so we get y minus 2 squared is equal to 4 times 4 minus 3. So we get y minus 2 squared is equal to 4. And then we can take the square root of both sides, so we get y minus 2 is equal to plus or minus 4. So y is equal to 2 plus 4, which is 6, and 2 minus 4, which is negative 2. So we have two values for y. So y prime at x equals 4 will have two separate values. So we evaluate y prime at 6. Well, when x is 4, but y is 6. So what's the best way of writing that? Probably the best way of writing this, we're going to look at y prime when x is 4 and y is 6. And that will give us 4 over 2 times 6 minus 4, which is 4 over 12, 8, a half. Then we need to find y prime when x is 4 and y is negative 2. So that would be 4 over 2 times negative 2 minus 4, which is 4 over negative 8, which is negative 1/2. Okay, so I have my y values, I have my x values, now I need to write the equation of the line. So we're going to have to write two different equations. When x is 4 and y is 6, the equation of the line is y minus 6 is equal to, and we found the slope here was 1/2, and x minus 4. And then when x is 4 and y is negative 2, we get y plus 2 is equal to negative 1/2 x minus 4. And we've written the equation of the tangent line. Now the reason there's two equations, because this is implicit, I'm not sure what that function looks like, but it could, it's not a function, actually it's not a function, it's a relation. So it could be something like this, like an ellipse or something. And so when x is 4, we could get two separate y values. And that's why we had two separate equations. Okay, I am going to give you a minute to do this on your own. Why don't you try this one on your own? And the answers, and we can put the answer, I'll have the answers online. Okay, the equation of the normal line is the same as the equation of the tangent line, except for the slope is perpendicular. So we would start by finding the derivative, which is 2x plus 2y, y prime, is equal to 0. And so y prime is equal to negative 2x divided by 2y, which is negative x over y. And we're told we want to find that value when x is 0 and y is 3. So y prime at that point would be 0 over 3, which is simply 0. And so the normal line for this would be undefined, because the normal line is the reciprocal, the negative reciprocal of the slope. So the normal line is undefined. And if it's undefined, that means that it has only has a vertical tangent line, so we would say x equals 0, because we get the x from here. Okay, so they want us to find an equation that has vertical and horizontal tangent lines. So we have to remember that a vertical tangent line occurs when the derivative is undefined. A horizontal tangent line occurs when the derivative is 0. So the first thing I have to do is find the derivative. So 8x plus 2y, y prime, minus 8 plus 4y prime equals 0. So solving for y prime, I get y prime 2y plus 4 is equal to negative 8x plus y. So y prime is equal to negative 8x plus y over 2y plus 4. Okay? All right, so they want us to find the vertical and the horizontal tangent line. Let's start with the horizontal tangent line. The horizontal tangent line is when the derivative is 0, and the derivative is 0 when the numerator is 0. So I have to set the numerator equal to 0. So I get y is equal to 8x. Now, how do I solve that? In this equation, every place I see y, I can replace it with 8x. Okay? Because I have, this is one equation and 2 unknowns, and this is another equation and it has 2 unknowns. So I'm going to kind of use substitution, systems of equations and substitution. So every place I see y, I'm going to replace it with 8x. So I get 4x squared plus 8x squared, which would be 64x squared, minus 8x plus 4y, so y is 8x, so this is 32x plus 4. So now I have one equation and one unknown. I can solve this, and this is all equal to 0. So I get 68x squared minus plus 24x plus 4. Let's go ahead and this is equal to 0. And we can go ahead and factor out the 4. And I don't have a calculator. 68 divided by 4. 1, 4, 28, 7. That's 17x squared plus 6x plus 1 equals 0. And then we could solve this for x, I'm assuming. I don't think we can, because it'll give us 17 instead of 6, so we'd have to use the quadratic formula. Normally the ones that you get would not be that bad, so then x is equal to plus or minus the square root of 36 minus 4 times 17 times 1 all over 34. So that's your value of x. It normally would not be that difficult. Now, to find the horizontal, the vertical tangent line, I have to set 2y plus 4 equals 0. And, well, that one's easy to solve, and that gives us y is equal to -2. And when y is equal to -2, we have to find the value of x. So we get 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. So that gives us 4x squared minus 8x, and that's going to be 0. So that's going to be easy to solve. We get 4x squared minus 2 equals 0. So x is equal to plus or minus radical 2 when y is equal to -2. So this would be the equation of the vertical tangent line. Okay, write a general expression for the slope of the curve. Find the coordinates of the point where the tangents are vertical. So I want you to try that on your own. It's basically the same thing that we just did, and the answers will be on Blackboard. I'm sorry, not on Blackboard, on the website. Okay, last one is to find higher order derivatives. So we're trying to find the second derivative. In order to find the second derivative, we got to find the first derivative. So finding the first derivative using implicit gives us 6x squared minus 6y prime equals 0. So y prime is equal to x squared over y. If I simplify that, so I subtract -6x squared divided by -6y, I get x squared over y. All right. So the second derivative, to find the second derivative, we have to take the derivative of this. And yes, we're going to have to use chain rule. So the second derivative, using chain rule, we get low times the derivative of the high minus high times the derivative of the low all over low squared. Okay? So what we see here is that we have y prime in our answer, and we don't want y prime in our answer, so we go back to the fact that y prime is x squared over y. So I substitute in y prime for, I substitute x squared over y for y prime. So I get y double prime is equal to 2xy minus x squared times x squared over y all over y squared. And of course you can simplify that if you like. Okay, you try this one, and again the answers will be on the website. So that's it for implicit. That ends Unit 2. I will probably give you some free response questions to do, because that's a very important part of this unit. All right, have a great afternoon.